So what I'm here to talk to you today about is actually Drizzle. And for those of you not playing along at home, all of this starts back around 2005. We're actually at this conference hotel, and we're meeting with a number of people like, say, Google and Facebook at the time. And I'm trying at the time to explain to them like why they're interested in MySQL 5.0. And so they look in the room and they're kind of like, well, I don't know about this whole store procedure thing. We don't really use them. The trigger thing, have you extended replication? And the room is very split. And the room is split between the people who, for instance, were embedding MySQL in companies like SAP who had made large investments in MySQL, and everyone had applications that were built in the 90s, not so much people who were building web applications then. And that day in that room, it was very, very obvious to me that we had kind of missed the path as far as the direction that people had actually wanted us going to. And on that day, I started scribbling down notes and asking myself and visiting people like Jeremy Zawadny and others at their companies, Craigslist, Facebook, and writing down things like, well, what did you actually want in the database? I mean, what are you cared about? What do you mean? Google actually goes into their code and actually puts if-defs around things like subqueries because it turns out that they don't actually want developers using them. What do you mean that you don't want these types of features? What exactly are you looking? So I went around and took notes for a long time. And then right about around when Sun buys MySQL, I had started working on an idea. Let's take the old tree. And it was just a plaything at first, something we had thrown up secretly on Launchpad that a few of us looked at, where we would remove things from it and say, well, what happens if we remove this feature? How much easier is it for the code to understand? Is the code faster if we remove this other feature? What exactly do people want to use? And we kind of left it up there for a while. And it kind of became a whispering thing where people knew about it. And it was slowly rolling and rolling to where one day, right before OSCON, it was pretty much obvious that lots of people actually knew that it was up the tree. And I went back inside of Sun and I said, we've had this project out here. And, we're going to go on and publish it and talk about it at OSCON. Of which I then immediately got a resounding legal threat, which then later found out. And it was interesting to watch Sun's internal machine move. At 9 o'clock, I got a legal threat of doing it, and by 11:30, I had gotten email from pretty much the president of the company and everything saying, "God damn, that's the best thing we've actually seen so far." And so it was a real interesting turnaround to see what actually had happened. So somewhere in that, if any of you are here on stage, you got to hear Drizzle would become MySQL 6.0. That was actually mentioned either last year or the year before. About around 2009, Oracle buys Sun. About 2010, of course, when the acquisition finally completes, all Drizzle developers, either that day or the week before, decide to jettison themselves. Because we're kind of pretty much still interested in this Drizzle thing. We wanted to kind of see it to a GA. And that really brings us where we're at today, which is 2011, which is where the first GA of Drizzle was released just not about a month ago. So what is Drizzle 7? What are the updates on this thing? Here's the basic architecture of it nowadays. Drizzle is a microkernel. It's not built like MySQL. It's not this monolithic kernel design. It's actually built up on a number of plugins. And all of these plugins enable us to write features very, very rapidly. We often have commentary internally called, is that old code or new code? Old code, very hard to change. New code, we rapidly change. We can write new plugin modules for anything that's in the new code very, very quickly. We have listeners, we have parsers. Our parser has been refactored down, has less than half the conflicts of the original MySQL one, and it's amazing. It turns out if you actually turn some knobs and cranks, turns out you can actually use a modern version of Bison where it'll even generate better parser code. Things like we have an optimizer. Our optimizer started to be pulled apart. We've also done things inside of here that we realized that people really were wanting that, how many times does somebody actually run a Cartesian join? I mean, on purpose. How many times have you been in a large company where somebody's like, yeah, baby, I had those two big tables. I wanted that Cartesian join. The answer is just because SQL actually lets you do something, it doesn't really mean you really want it to do. In Drizzle, can you do a Cartesian join? Yes. Can you do one by default? No. Here's the deal. You actually have to know how to put together the predicates in SQL to generate an actual Cartesian join. And the thing is, almost nobody knows how to do that. And the reason why is because nobody ever actually needs a Cartesian join. There's just a lot of things that are built in the system. We spent a bunch of time working on things like the storage engine interface, though in truth what we have learned at the end of the day, our internals is InnoDB. It is fairly latest version of it. It has some modifications to work better with Drizzle, and it's got Percona patches in it. That's what turns out what the majority of people actually want. That is the thing. That is what we try to focus on, and everything we generally consider ourselves is as a relational transactional database. That's what we are by default. Other things. We removed an awful lot of gotchas. There are times when you're saying, well, I don't want this thing to be null, and yet null data ends up in your table anyway. You know how confusing that is? You know, the biggest problems we've had with people moving from MySQL to Drizzle is they'll find like, well, what do you mean? Your tool had extracted it said I have all these nulls in my table over here, but I swore I declared that table not null. You probably did. You probably look at your client application. Oh, it's an enum. It's yes, no. People have been inserting the word dog. Sorry about that. Somehow that ended up being wrong data. Alter table. How many times people type alter table and it just runs magically? No, yet when you actually look at it, you're like, really, like we didn't have a default value on that thing. There was nothing there that says what the data should have been when we did an alter table. What exactly just happened? Well, that was SPOO, your entire database. It's got no good values left in it. What's happened? You've just corrupted everything. Because once you start putting bad data in, it just keeps going. So we don't have any of that stuff. We have a real date time. What does that mean? It's actually 64-bit. It's from day one, 64-bit. It's in the system. When you complete tables, it's all there. The difference between date time and timestamp, very minor. And oh, by the way, if you want microseconds, we go on and store the actual microseconds at the end of the row as well. So if you want them, they're actually there. And it's something I forget. I'll walk into someplace and they're like, IP version 6. Do you guys support IP version 6? We've supported it for 3 years. I forget the fact that it was even there. People ask this question. I'm like, oh, do applications still not support IP version 6? Yeah, it's all in there. No updates at half complete. You don't have to worry about you're running an update and suddenly the update finds that something isn't correct and so it stops and then suddenly half the data in the database has been updated. You don't want that. You want the stuff to either go in or roll back. You don't actually want it to give you half corrupted data. That's not what you're interested in. A few other things. The web is UTF-8. The number of times I went into people and said, so how's the Drizzle transfer going? It's great. We've been importing all of our Indian data, all of our Hindi. And I'll be like, well, curious. What was your original table type? And they'll go, well, let me go back to show create table. Hey, does Hindi fit in Swedish 7? Because that's what this thing says. It's been inserting OK. Is my data actually still there? Yeah, your data's there in some form. The web is actually UTF-8. When I gave this slide a couple of years ago at the International PHP conference, it was interesting. The whole group of them were all like later on like asking me like, hold it. You're just saying you're saying the web is UTF-8. Why haven't we just made PHP UTF-8? Why did we do this UTF-16 thing? We actually had a study done at Mixie where they discovered that because so much English goes into their language nowadays, that UTF-8 is just as nice as UTF-16. The whole comment that, you know, UTF-16 be better storage for Asian, turns out it's not true because our languages nowadays are so actual intermixed. A big thing we started on early on was replication. And this actually comes from a lot of discussions with companies like LinkedIn and others where we are asking them, like, what's your future architecture? Well, your future architecture in their environments is where they were creating data buses, places where they could actually take their data, transfer their data, and they had this bus. They didn't really need us to necessarily be the stream for their data. They had that covered. What they had was a data bus. They had a way of transferring data back and forth between Colos environments, and they wanted us to live in that environment. And if there's something that Drizzle does really well, is that we are not an island unto ourselves as a database. What we are is infrastructure. I like that word a lot more than I like cloud, and because it means a lot more to me. We're infrastructure. We are a piece, a gear of sorts that actually sits right inside these environments, and we are designed so that we integrate well and quickly and easily. So our replication is actually an open format. It's called Google Proto Buffer. You can download the libraries. What it does is it takes all that data that would generally be done in some kind of a binary representation and stores it in a serialized representation that then we have libraries in Python and in Perl and in Java that can be pulled from it. I wrote the first replicator we had close to 2 years ago in Python, and it took me about 30 minutes. It really was not that difficult. It actually replicates based on row transformations. We track the deltas that are being changed in the database. So we track those deltas. It is not a statement-based replication. Though, like a statement-based replication, we can actually tell you the SQL that actually generated this. So if you want to see the SQL, we can do that. But our transfer method is actually based on deltas. Because there's a conversation I never want to have with the users again, where I have to do this song and dance of, well, was your application written deterministically? Well, if it was written deterministically, then it'll replicate it well. If it doesn't, then it's not. And because, trying to tell people, well, you need to do this and that in your application, but this and that won't work, and oh yeah, sorry, forgot about that. All of these little parts are just a pain. Nobody wants to know that. And the other thing is it's already integrated with other things today. We integrate with RabbitMQ. We integrate with Cassandra, Memcached, Gearman. There's a demo that went up on Planet Drizzle about a week ago where there's a Rabbit replication system where this fellow has incoming data that comes into Drizzle. Drizzle actually then replicates it into RabbitMQ, and that RabbitMQ then sends it to browsers for real-time data. So everything goes into Drizzle, gets stored in a nice, transactionally safe environment, hits out, and then goes back out to browsers. That's pretty cool stuff, people. And like I said, this stuff is all actually stored transactionally. So what does that mean? Okay, so how are we doing it? What we do is we actually use InnoDB. Funny thing, it turns out along the way, we actually have a transactional store. We don't actually need to write a whole entire other file that we have to then do this song and dance about group commit. And do we have group commit fixed today? And we had group commit fail yesterday. And oh God, yes. Turns out group commit, we definitely got it working this time. No way are we going to break that in the future. Well, the answer was, why bother with that stuff? We can actually store it directly inside of InnoDB at the same time. One sync call, guess what? Sure, it takes up a little bit of extra space, but you were already taking up the extra space anyway. From the bin log itself. Now it's just all nice and containered. When you run a backup, you get the whole thing. So, because the group commit thing is a real pain. You've got this bin log, and you've got this database. And what's happening? You're sitting here hoping that your sync works. You're hoping that no data corruption occurs. And the thing is guess what? InnoDB, the same thing you trust your data to, is so much more intelligent than the bin log. Why bother with the bin log? So in our case, we have no group commit required. Everything goes into InnoDB as we do inserts. We pull it back out. We do not do a replication where it is a transfer of block. Why not? Because we live in an environment where we know people want to extract that data, and they want to be able to use that data elsewhere. They don't want us to know that, yes, we could transfer ourselves to ourselves. We could figure out a way to do that, binary transfer the logs. Big deal. You want to be able to extract your data, pull that data out, and replicate it into whatever else you need. Because most likely, it's not that you have just another database on the other end. You can actually have analytic systems. You can have Hadoop. You can have any of these things. Having your data trapped in a format where it cannot be transferred is a disaster. And so we don't make it that. So anyway, there's a talk later today on more replication stuff. So you can kind of hear all about it. A couple things. It's a single sync. It's entirely transactional. It's a scatter-gather. Okay, what does that mean? So in MySQL, if you have a transaction, especially a long-running transaction, and especially in a row-based transaction, what it'll do is it'll start filling up memory because it has to keep and track the whole thing in memory for a while. And what happens occasionally? Occasionally it runs out of memory. So it goes what it does, it lays it out on disk. What happens when you finally have to do a commit of this thing? You have to pull it off of disk, write it back all over again. Screw that. Why bother that in the first place? We drop it actually inside the log as it moves along. It means that our slaves have to be a little smarter. Our slaves have to understand the concept that a transaction is a transaction. So what it has to see is, look, we have a transaction. Does a rollback occur? Did a shutdown occur? For that little bit of extra logic that's required actually in the slave servers, we gain such a huge win in I/O and in general performance. It's great. No concerns about determinisms. You get to sleep at night. It's no longer this whole question of, hey, my slave, it somehow died. It got off-synced with the master. What exactly is going on? Oh, it turns out that on your master, you only have, of course, the bin log syncing every like 5 seconds or every 5 times. And you do that because you can't handle the I/O. Well, with us, it's just built in, goes directly into the transactional log, done. Much, much simpler. So another big thing, libdrizzle. One of the things that actually Sun let me actually do at the time was actually take our drivers and actually bring in drivers that were BSD to solve this whole question. Well, is it a GPL? Is it LGPL? Is it this or is it that? It doesn't matter. Our drivers are BSD. We did it when we were still at Sun. Sun sanctioned the whole entire thing. They work with MySQL. They work with Drizzle. They work with SQLite. We have JDBC version. The JDBC version has become pretty popular with people who are trying to ship MySQL. Just because why? It's a driver that's actually out there. It's been used. And, well, it is free. More importantly, it's lawyer-free. We don't have to have a whole lot of discussions of, oh, your server's GPL and the client library is this, but I read on Brian's blog site that GPL doesn't follow protocol, but I read that, can't all that stuff. GPL doesn't follow protocol. These are BSD drivers. We have them inside of Sun. We continue to actually release them. Even if you're not going to use Drizzle, it is something to think about using and extending, just because in the end of the day, you really don't want to have to be sitting around and having these conversations. On the whole NoSQL thing, just to trot ours out as well, in our case, we actually have Blob Streaming. This is something Primebase added quite some time ago. It allows us to actually hand back a URL. I know that's an incredibly complicated API to use, but when you select back, we hand you an URL. That URL you can fetch, and that URL can actually be a blob that is stored up on Amazon S3. It is a blob that could be stored locally. It doesn't really matter. So how's that for instant NoSQL? We can just be just like everybody else. Is there more? There's a whole lot more. When I get into this stuff, we've been developing this thing for 3 years. I've been using it like on my own servers for probably about close to 2 years at this point. I don't actively remember the differences between MySQL and Drizzle anymore. It's one of those things that just doesn't happen after a while. I just don't really remember it. So sometimes when I go out and I'll find new users, they'll be like, yeah, this was. And I was like, oh yeah, we did that 2 years ago. I can't remember if we put that in the manual yet. Oh well. No cost auth. We can actually authenticate against PAM, LDAP, HTTP. You'll find in most of your distributions, Drizzle's nowadays there, and the auth modules are set up. We have table functions. The problem with, of course, the information schema is that it generates itself. It's these large in-memory tables that then are not really directly inside of the same execution path as the storage engine, so you end up with bugs that are related to like only information schemas that aren't related back to actual storage engines or table lookup. This is the problem we call the multiple execution path problem. We kept finding in the source code multiple execution paths, so we'd find bugs that, well, this bug wouldn't happen if we did this, but we'd bug that we do this. And yet it was basically the same function above and under a hood. The multiple execution path, where often somebody thought they could optimize something. But the problem is that one little optimization later on led to very indescribed behavior actually in the server. So we have that. We have a data dictionary. If you want to find something that's not in the SQL standard, go to data dictionary. We have a thing called information schema. That actually follows the SQL standard. We spent a lot of time trying to figure out what exactly is the SQL standard when it comes to information schema. And we put just that data in the information schema. And I tell you, not all the database vendors got that right. More often than not, I had to have a window open most days to this thing called SQL Zoo. And SQL Zoo has a number of databases on there. And I would sit around and I would type something into one database. So I would type it into Postgres. I would type it into Oracle. I would type it into MySQL and see what the end result was. And then sometimes, of course, and I would be IMing Josh Burkus going, hold it, Postgres didn't behave the same way IIS did. Who's got the bug? Sometimes, for instance, it would actually be IIS. Occasionally, it would actually be Postgres. More often than not, it would be me who hadn't typed the thing in correctly. But, which I thank him for his patience of. We have UUID types. They're built into the database right now. They're kind of neat. If you can actually select one, you can select one as a date and time, and it'll tell you the date and time the UUID was created. So you have one type there that not only gives you a unique ID, but at the same time gives you built-in timestamps immediately inside the type. Kind of neat. We have all the types except for set, as in written in the MySQL documentation. It's kind of broken by design. That's the one that we haven't done. I've got a student this summer from Google that's actually going to write out one that's going to actually work correctly, and we're going to index it correctly and everything else. And we have a thing called tuple, which will also give us, an object store there. You don't have to have, kind of a loosely typed thing like JSON. So where are we actually going in all of this stuff? So Drizzle 7. We're going to update replication in Drizzle 7 Plus? Yes, we're going to update it. So everybody's accustomed to this environment, right? You got a master, you got slaves, same thing we've all been doing from the beginning. How about this, though, instead? What if actually we can actually do MultiMaster? I know, it's a crazy thought. We've all been wanting it. So inside of actually, in one of the sub-Drizzle trees, that'll go hopefully into main pretty soon, we now actually have MultiMaster in the database. This means that a single master can have multiple slaves, slaves can have multiple masters. It's an entirely peering network. And so you can end up things like this, where you have masters that can sit there and be feeding each other back. And I think the more important one, which is the flip side of this, All of you all who are now sharding your databases, you've got 10 shards sitting up here. You have 18 shards that are working. You can take all those shards now and push them all back to a single database, i.e. they can all replicate back to a single database. That slave there means that you can actually then have an analytic version of Drizzle set up that can do all your analytic reporting and still get all the advantages of sharding. So it's nice. All the advantages of sharding, front ends, with a single backend that's pulling all that data together and actually giving you the ability of doing analytics. That's neat, people. That solves a big problem. That gives you a place where you can actually scale up and actually do something with the database. And we actually have built into our drivers that are starting to work this summer built-in sharding mechanisms. We're going to basically take all the code that I've had for years that runs in libmemcached, all that stuff that pretty much powers every single website you see today, all the sharding built in, is all going to go right back into our client code. And then our client code is going to be able to actually handle sharding for you, and we're going to be able to rebuild in the back end. Let's kind of simplify this stuff. This is another big project that we actually worked on. This right here is you think of the database, you have an instance, you have some schemas, you have some users inside the database. Okay, problem is what happens when you virtualize this? Virtualization of a database is a bad idea. A database is an operating system that we thankfully don't have to write sound drivers for. And this right here, what we've got in the beginnings of the 7+ tree is actually the ability to do what we call catalogs. And each catalog is a separate running instance inside of Drizzle, all maintained by a single instance of Drizzle, but with the bigger pieces. You cannot select across catalogs. Catalogs have no execution path. There's no way to even do it. But what we can do is we can control the number of threads allocated. We can control the amount of disk space that is allocated. We can essentially let you take one box and turn it into that big virtualized server without paying the 30 to 40% hit from virtualization. You know, virtualizing a database is really expensive. You're throwing away a lot of machines when you start doing that. The idea with this is, hey, maybe we can save the planet a little bit and give you that virtualization built into the actual database. With Auth, the advantage, you have one single instance to manage. So you're not having to manage all these additional databases, and for that matter, all these operating systems, all this other stuff. You manage one database, everything goes in it, you're set. Still allows for I/O to be spread across SAN and NAS. That's actually what we believe is part of the future. Another big thing, Percona's hot backup. When you download Drizzle today on the 7+ tree, what do you got? You actually have an actual hot backup available. This is Percona's software. We have taken it, we've updated some pieces to it. We are continuing to take pieces from them and actually provide patches back to them as best we can. And if this thing comes, we now have a backup solution. And by the way, since our replication is in our transactional tables, guess what you can do with a hot backup that's running with Drizzle? You actually get to back up all of your replication logs, your point-in-time recovery logs, with no bits of hands or hand waving or dancing or anything. It all just built in. It's one of the big advantages of a whole built system. So this is the thought moment for this conference. Was it actually all worth it? Could we have? There's a lot of things that people have asked us in the last few years. Could we have done this? Or questions of, are you still working on Drizzle? Things like that. Could we have built it from Postgres? That gets asked a lot. I blogged about it. The answer is, we could have. Sun probably wouldn't have paid for it initially, but we could have done it. It's a good database. Would have worked a bit. It would have taken some effort to make it go from C to C++, but it would have worked. What is a rat hole? This often comes up in the mailing list. So-and-such said that such and such tomorrow is in a rat hole. A rat hole is where we started to do lots of testing. Drizzle is easily the most tested version of MySQL that has ever existed. We test at a ridiculous amount. We test everything you can imagine. We test for every single push, every single pull. And what rat holes are is where we find bugs. And sometimes we find fundamental bugs in the system. I had to spend a month and a half, 4 months before we had GA, fixing time-related issues, where I had to learn all kinds of things about Gregorian and Julian time and all kinds of details about time I never knew about. And why? Because we found so many bugs. And all that happened was one day, one little thing went wrong in our testing system, and we had to find it. And these are what are called rat holes. We have fixed a lot of rat holes. Do we still have bugs? We still have bugs. We have plenty of bugs, like every other piece of software. But that was something that came up. Should we have rewritten in Erlang? It's been one of the questions that come up. We get lots of stuff like this. What does the cloud mean, other than something fluffy? The cloud really, to us, means more, what is infrastructure? How can we write a database that in itself, not an island unto itself, that we know from day one is a part of the stack? People just don't install a database nowadays and just sit there and go, I'm going to insert queries on the command line and then select stuff. And I'm going to tell my wife to use this as well. It's all great. We'll keep our groceries list on it. People don't do that. The database itself is just another piece of infrastructure. And it has to integrate and it has to work alongside everything else. So the big thing, though, what was actually the big win in this whole thing? What really occurred out of this whole thing? Because as a technical problem, it was a challenging problem. But a technical problem as it is challenging, I work on Memcached and Gearman. We've got crazy-ass problems we solve with Gearman. I have other technical challenges. So this was the big win. 120-plus developers since day one. We averaged 26 to 36 on average each month developers pushing code. We are easily the largest and most adopted versions of all the forks. And part of this is a kind of a, I was told many times, there's no way we can actually take contributions from people. It will be too hard. There will not be enough out there that can be done. They won't be able to understand it. They will not be able to touch it. For whatever reason, we cannot allow them to actually, do patches. Let me tell you, that is not true whatsoever. The answer is we've had students who just come out of college, first, second-year students, who show up, who learn just some C++ and go through our code and find things we missed or things we didn't know about. They're fresh in school still studying it. They provide patches back. And they come from all over the planet. They come, when you least expect them. And it's great and it's wonderful. And the truth is, we can take a lot of contributors. It works. It's a good thing. Open source actually still functions. The comment that lists all open source now must be done by professional developers and large enterprises is horseshit. Fact is that there's an awful lot of open source out there that is still being done by students, people in their, in the evenings when they're into the day of the job. There's all kinds of open source being created today, and it's all being used. And the fact is these are people from all levels of development. And that is what actually has been great about Drizzle as a project, is we've got to meet a lot of those people, and we continue to meet those people. And that is pretty good. And you know what? Companies support us. Rackspace, Mine, Data Differential, Blue Gecko, Intel, all these companies have been supporting us with machines, help people. Rackspace funded us through our entire GA process, gave us money for conference. And that was an awesome thing. And you know what? After that, all of our devs at this point, they were like, fine, we'd like to now see where it works in the market. All of our devs immediately started getting hired up at other companies and get moving on. And suddenly we have yet another wave of companies asking for Drizzle developers. The process just continues. It's great. So one thing, on Friday we have a Developers Day. If you'd like to learn how to write documentation, if you would like to just hack on something for a few hours, if you're just kind of curious about the thing, you can come for a full day. We've got a conference room. You can find it on drizzle.org. You can find out the information on it. I know we still have spaces on it. If the website tells you we don't have spaces on it, just come anyway, because honestly, those things always lie. So last bit of stuff. If you want to find out some more about Drizzle, go to drizzle.org. Domain name actually was done by the community. I just woke up one day and discovered we own drizzle.org. How's that for fascinating? Freenode, pound drizzle, you can go there. We are not a very mailing list centric people. We actually are actively, we do so much active development, and we're so actively engaged that generally mailing list has not been the greatest place in the world. Find us on IRC. We live on IRC. If you want to know more about me, that's my blog address, that's my Twitter address. And I believe I am out of time or over time, so I thank you all very much.